Welcome to class. Today, we are going to review how to solve quadratics using square roots, and we are going to learn how to do something called completing the square. So you can actually solve quadratics by completing the square. And what's nice about doing it this way is you also get the vertex at the same time. So some people prefer this method because you get the vertex, you get the solutions. It can be kind of tricky depending on the problem, but let's just start off with a quick review. How do you solve quadratics? Okay, remember we've already talked about this. If you have something to the square equals 100, you take the square root of both sides. And so you would get x minus 8 equals, and that's going to be the positive and negative square root of 100. And the square root of 100, 100 is a perfect square, so that just makes 10. So I get x minus 8 equals plus or minus 10. I add 8 to both sides, and I get x equals 8 plus or minus 10. Doing that real fast in my head, I do 8 plus 10, I get 18. I do 8 minus 10, and that's negative 2. So this is kind of what we're going to be doing, is we're going to try to make our quadratics look like this. We're going to make it be called what's a perfect square. And because once we have a perfect square, we could take the square root of both sides. Not quite sure we need 3 of these, but it never hurts to do more review. So I already got squares, so I take the square root of both sides, and I get x plus 4. And this is going to be plus or minus square root of 25. Remember, when you take the square root, you have to consider the positive and the negative. But the square root of 25 is just 5. Over here, I have x plus 4 still. This time, I'm going to subtract 4, and I get x equals negative 4 plus or minus 5. Doing the math there, I'm going to do x equals negative 4 plus 5 first. That'd be x equals 1. And then negative 4 minus 5 would be negative 9. Those are my 2 solutions. And then finally, I cannot take the square root of both sides because I have a 2 here. So the first thing I would do is divide by 2. Twos go away. And now I get x minus 7 squared equals 20. Now when you take the square root of both sides, it gets a little tricky because you get x minus 7 equals plus or minus square root of 20. And then depending on your teacher, some teachers are okay with you just changing the 20 to a decimal. I think I'm okay with that too, but technically what's better is to think about 20 and how to reduce that. And 20 is the largest perfect square that goes into 20 is 4. So I'm going to think of that as square root of 4 times square root of 5. And I know that the square root of 4 is 2. So I get plus or minus 2 square root of 5. And that's x minus 7 equals that. Add 7 to both sides, and I get x equals 7 plus or minus 2 square root of 5. Now, it may be tempting to go, you know what, 7 plus 2 is 9, but you cannot combine those two because this is a 2 square root of 5, that's a 7. And if you really, really, really wanted Desmos, graphing calculator, scientific, I would type 7 plus 2 square root of 5. And notice that's 11.47. And then 7 minus 2 square root of 5. These are what we call the exact answers. Those are much better to have. And then just checking my work real fast. Let's see, if I minus 40, that'd be 2x minus 7 squared equals, or 2x minus 7 squared minus 40. So if I look at the x-intercepts, look, we got 2.528. I sure hope that's what I got. Yep, 2.528. And I got 11.472. That's exactly what I got there. So it is better, this is called an exact solution. It's better to have exact than an approximate. Okay, and in case you're wondering, why did I type it in that way? Remember, the easiest way is to make this equal to 0. So I subtracted 40 from both sides, and I got 2x minus 7 squared minus 40 equals 0. And that's exactly what I typed in. All right, so that is all review. Now let's go to completing the square. And I want you to notice that we're starting off with a equals 1. These are the easy ones. And then we're going to do when a is not 1. These are a little bit more tricky. All right, so let's go ahead and start. All right, the first step you want to do is you want to move your constant over. So you want to take the 7 right here, and you want to move that to the other side. So I get x squared minus 10x equals negative 7. Now your second step is you're going to take this number right here, and there's a process. You take that number divided by 2, which is negative 5. And whatever you get, you square it. So negative 5 squared, negative 5 times negative 5 will always be positive. So anything you put in here will always be positive. So I could just ignore the negative and go 5 squared is 25. So what you're going to do is you're going to add 25 to both sides. So I got x. Oh, where's the square button? Squared minus 10x equals negative 7. And what I'm going to do is I am going to add 25 to both sides. Now you may be asking why? Like, why do that? Well, the reason why you do that, and I could do a better 5 than that. The reason why you do that is because this one right here, that becomes what's called a perfect square. So remember when you factor this, remember you put 25 on top and negative 10 on bottom. Because you did something called completing the square, the number on the left and the right are going to be the same, always. So what multiplies to 25 and adds to negative 10 That'd be -5 and -5. And what do you get as your factors? You get x minus 5, x minus 5. But x minus 5 times x minus 5 is x minus 5 squared. Okay. And I forgot to do the right side. Whatever you add to the left, you add to the right. -7 plus 25 is 18. So I get x minus 5 squared equals 18. Now, why would I do that? Because look, now it looks just like those. So I have a square, I square root both sides, and I get x minus 5 equals plus or minus square root of 18. So plus or minus square root of 18. And then I think of the perfect squares, which are 1, 4, 9, 16. 16 does not divide into 18 evenly, but 9 does. So I could think of this as 9 times 2. But the square root of 9 is 3. So that reduces to plus or minus 3 square root of 2. And over here is still x minus 5. To solve this, I would add 5 to both sides, and I get x equals 5 plus or minus 3 square root of 2. Okay, so those are my solutions. 5 plus 3 square root of 2 and 5 minus 3 square root of 2. Now they also said, solve the following by completing the square, then identify the vertex. Well, that's what's nice about solving it this way, is right here, this is vertex form. Well, almost. You would have to change this to get vertex form. That would be x minus 5 squared minus 18. So you would say the vertex is, remember it's the opposite of this, same as this. So it'd be 5, negative 18. Now there's a lot going on here, so I'm going to check my work. And the way I'm going to check my work is I'm going to type this in, x squared minus 10x plus 7, and I'm going to go look and verify some of this. All right, let's first verify the vertex. I think the vertex is, okay, well, I know based off the graph, it's 5, negative 18. Where did I put it? 5, negative 18. And then I think that the solutions are 5 plus 3 square root of 2 and 5 minus 3 square root of 2. So that'd be 9.24 and 3.58. Let's see. 9.24. Uh-oh. 0.757. Oh, I left off the 3.757. There we go. Okay, so that is the process of completing the square. It's nice because you get the vertex and the solutions all in one. Let's see. And we don't have time for 4 of these. Let's try B. I don't think there's anything different. Oh, yeah, I see what C and D is doing. All right, doing the same process. I move the 4 over. So I take this, I move it over. That makes a plus 4. So I get x squared plus 8x equals 4. I then take this number, 8, I divide by 2. That's 4. And I square that number. 4 squared is 16. It's better to put this in parentheses, I think. So that's the magical number. I am going to add 16 to both sides. X squared, plus 8x plus, leave some space, equals 4 plus something, okay? So we are going to add that to both sides. 16, 16. All right, now what's going on here? What multiplies to 16 but adds to 8? That'd be 4 and 4. So you're going to get x plus 4, or just x plus 4 squared. Notice I skipped a couple steps this time. 4 plus 16 is 20. I take the square root of both sides because I got square by itself now. And I get x plus 4 equals plus or minus square root of 20. I think of the perfect squares, 1, 4, 9, 16, 25. 25 is too large. 16 does not go into 20. 9 does not go into 20. 4 does. That'd be 4 times 5. Square root of 4 times square root of 5, which is 2 square root of 5. Why? Because the square root of 4 is 2. I subtract 4 from both sides, and I get my solution is negative 4 plus or minus 2 square root of 5. All right, now another question was, what is the vertex? Remember, the vertex could be found right here. If I bring the 20 over, that becomes a minus 20. So my vertex is going to be opposite of this. And then I usually say same as that, but since it's on the other side, it's going to be opposite too. Just like here, it was basically opposite because they're on different sides. But if I move that 20 over, it'd be opposite same. So it's going to be negative 4, negative 20. That's my vertex. Never hurts to check my work, right? All right, so x squared plus 8x minus 4. X squared plus 8x minus 4. Oh, what's my vertex? My vertex is negative 4, negative 20. What did I say? Negative 4, negative 20. That's my vertex. Why did I not use the text box? I don't know. I just wanted to show you how sloppy my handwriting could get. Let's see. Let's look at the solutions. Negative 4 plus 2 square root of 5 and negative 4 minus 2 square root of 5. By the way, I didn't mention this, but to get the square root, you just type in SQR, and then as soon as you type in a T, changes that to square root. Okay. Might as well do copy paste, change that to a plus. So here's what I think the answers are. Negative 8.47 and 0.47. 0.47. Negative 8.47. Okay. All right. Now, we don't have time for these two. I'm going to cross those off. Now, what makes these tricky is because when you're taking this and you're dividing by 2, you get a fraction because that's an odd number. So like when you take that divided by 2, and then you square it, you actually get 25 over 4 because you square the 5 and square the 4. And then you have all these like fractions and stuff. Completing the square is okay, but anytime this number is odd, me personally, I would not complete the square because you end up with fractions. So that's why on these, just to keep it easy on you guys, we're going to cross those off. Okay, we're only going to deal with even numbers, even though, you know, like half the numbers are even, half the numbers are odd. Just to keep it easy, we're going to keep those even for you. Okay. Now, these are different. What makes these different, I want you to see we have a 3 out front. When we did ours, we had a 1, a 1, a 1, and a 1. So these take a little bit more time. You still do the first step. You still bring the 15 over. You still bring that over. Da, da, da. Okay. Now you have 3x. Might as well use the space we got, huh? 3x squared plus 12x equals negative 15. Now here's where it's different. We want to get rid of that 3. We can't just get rid of it, so we factor it out. And 12 divided by 3 is 4x. And then we complete the square. But we're going to complete the square by taking this number, 4. You take that, divide by 2. Well, that's easy. 4 divided by 2 is 2. And 2 squared is 4. We're going to add that to both sides. So we're going to put plus 4 here. Let me type this in again. Actually, I can just do that. 3x squared plus 4x plus something, don't need that much room, equals negative 15 plus something. What number? We're going to put 4 in there. Here's the common mistake. Kids go 4, and then kids go 4. That is a mistake. Why? Because this is actually 3 times 4. So even though you're putting a 4 there, you're actually adding 12 to both sides. So this over here should be a 12. That is the common mistake right there. All right. Well, something doesn't look right. Negative 15 at 12, 2, 4. Okay. From here, I factor that. What multiplies to 4 and adds to 4? That's 2 and 2. So that'd be x plus 2 squared. And then negative 15 plus 12. That's negative 3. And then this is just like what we did at the beginning when we had, where'd you go? This one. Remember how we had to divide by 2? Well, I need to divide by 3. Boom. That'd be negative 1. So I get x plus 2 squared. And negative 3 divided by 3 is negative 1. We're about to take the square root of both sides. When you take the square root of a negative, that makes imaginary. So when we're checking our answers in a second, we should not see any x-intercepts. So when I take the square root, I get x plus 2 equals plus or minus the square root of -1. Remember, you could take the negative out and makes it an I. Square root of 1. But the square root of 1, 1 times 1 is 1. So you just get plus or minus 1i. Subtract 2 from both sides, and I get x is -2 plus or minus 1i. All right, checking my answer. Vertex would come from here. My vertex based off this, vertex would be -2, +1. Remember, if I move the -1 over, it comes a +1. Let's go check our work. So typing 3x squared plus 12x plus 15. Just what I want to see. No x-intercepts. But the vertex is -2, 3. Oh boy. I almost made a mistake. Because it's before you divide, so it's going to be -2, and then you move the -3 over, it'd be +3. I almost said the wrong thing. That should be a 3 because of that -3. All right, so that's why it's imaginary, is because it does not cross the x-axis. I think I have time for one more. Okay, this one, I would add 11 to both sides, and I get 4x squared. I have to go a little faster here. I'm running out of time. 4x squared plus 24x equals 11. What do I add to both sides? Oh, I need to factor out the 4. Almost forgot. So that'd be x squared plus 6x equals 11. And then what do I add to both sides? You take the 6 divided by 2, that's 3. 3 squared is 9. So you're going to add 9 to both sides. I took 6 divided by 2 squared. That'd be 6 divided by 2 is 3. 3 squared is 9. That equals 20. So now I got 4. What multiplies a 9 adds a 6? 3 and 3. So it'll be x plus 3 squared equals 20. Let's see. Divide both sides by 4. 20 divided by 4 is 5. Take the square root. Don't need parentheses anymore. That equals the square root of 5 plus or minus. Subtract 3 from both sides, and I get x equals -3 plus or minus square root of 5. Now, why did I not break 5 up more? Because 5 is as low as it goes. 5 is what we call a prime number. All right, so checking my work based off this, the vertex should be opposite of 3, -3. Because the 20 is on the other side, opposite of 20, -20. Check our work. 4x squared plus 24x minus 11. I think I said minus 11. I don't remember. Yes, I did. Let's go look at the vertex. Vertex is -3, -47. Oh no. I did not get -3, -47. What did I do? I did the most common mistake ever myself. Remember, you don't add 9 to both sides because that's really 9 times 4. I did that on purpose. That's 4 times 9. That's 36. That should be a 36. If I'm being completely honest, I did not do that on purpose. 11 plus 36, that changes that to a 47. Which will make the vertex negative 47, which is what we had, right? Negative 3, negative 47? Yes. All right. Oh, 47 divided by 4. 11.75. This is probably one where right? Yeah, oh, 11.75. This is probably one where, oh, wow, I did not want that. I just wanted that. Oh, come on, man. I don't know why it wants to take off the whole. No, don't do that. I just want this one, just that. Oh, all right. Well, this should be, I don't know why it's doing that, guys, but this should be 11.75. And I would just type that in your calculator. Wonder if it'll let me get rid of this. There we go. There we go. Thank you. You can't really do anything at 11.5 or 75, so just type it in. Square root 11.75. That's 3.43-ish. So now it'd be x plus 3 equals plus or minus, what did I say? 3.43. Subtract 3 from both, you get x equals negative 3 plus or minus 3.43. I take x equals negative 3 plus 3.43. I could do that in my head. That just be x equal 4.43. And I do negative 3 minus 3.43. That'd be negative 6.43. Well, nice one off on me twice. I'm taking forever. All right, let's go look. 0.43. 0.43. Show me 0.43. 0.428, just because I rounded. And then the other one, negative 6.43. Show me. Ha, there we go. I feel good. Notice I check my answers too as I go. I'm human, I make mistakes, so do you. Just want to double check. Number 1 is even, number 2 is even, number 3, 12 is even. You should be good on those. We're going to actually cross this one off because I don't want you to mess with anything that's odd. That's odd. And that's odd. So you can cross off 4, 5, and 6. Here, make sure you factor out a negative 2 at the beginning, but then that'll be even, so we're good. Factor out a 4, which changes that to a 4, we're good. Factor out an 3, that makes that a 6, so you should be good. Factor out a 5, that becomes 3/5. Again, we don't need to do anything crazy. Get rid of that. That's going to become 2/3. No. And that's going to be okay. So I will change the assignment shortly so you can see I made it just the easy ones because I'll be honest, these are kind of a pain when you have odd numbers in the middle or you create fractions. Okay. And I would not solve by completing the square when they're like that anyway. So why show all the tedious stuff? So that's all I have. I will update the assignment. Have a good day. Nice seeing you all.